Good morning, students. Today we will be starting with exercise 7a, question number 7 and number 8. Alright, so question number 7. Now in the figure, AB is equal to CF, EF is equal to BD, and angle AFE is equal to angle CBD. So what do we have to prove? We have to prove that triangle AFE is congruent to triangle CBD. Alright, so in this case we have to show that angle 1 is triangle 1 is equal to triangle 2. Alright, the first condition, AB. Alright, AB is equal to CF, then EF is equal to BD. Alright, and triangle AFE. So AFE, so this triangle AFE will be equal to triangle CBD. Alright, so this is very simple. So what we will do first is that now since AB, alright, now since AB is equal to CF, now we have this line segment BF. Alright, so if we can only show that AF is equal to CB, then we can use side angle side property and we can show that the two triangles are congruent. So in this case what we will do is now this line segment BF we will add to both line segment AB and CF. So in this case AB plus BF will be AF. Alright, and CF plus BF will be equal to CB. So in this case AF will be equal to CB. So in this case we have shown that AF is equal to CB, so therefore we can use SAS property and the two triangles are congruent. Alright, so given you will write we have AB is equal to CF, EF is equal to BD, and angle AFE is equal to angle CBD. Alright, so to prove what do we have to prove? That triangle AFE is congruent to triangle CBD. So let us prove this one. So proof. Alright, so you write we know AB is equal to CF. You name this as equation 1. So what we will do is adding BF, alright, to both sides of the line segment. Adding BF to both sides. In equation 1 we get AB plus BF is equal to this is CF, alright, not CP. CF plus BF. So AB plus BF, so AB plus BF we will be getting AF. Alright, so AF is equal to BC. Alright, so this is equation number 2. So now since we have proved that AF is equal to CB, we can show that the two triangles are congruent. So you write in triangle AFE and triangle CBD, you will write AF is equal to BC here from equation 2. All right, then angle angle AFE is equal to angle DBC. This is given from the question. And line segment EF is equal to BD. All right, this is also given from the question. So since it fulfill the three criteria, side, angle, side, we can say that the two triangles are equal. All right, so therefore triangle AFE is equal to triangle CBD by side, angle, side. So here it is since. All right, so therefore triangle AFE is congruent to triangle CBD, all right, by CPCT. All right, so this will be your answer for question number 7. All right, students, we have completed with question number 7. Now we will be starting with question number 8. So in question number 8, in triangle ABC and PQR, AB is equal to PQ, BC is equal to QR, and CB and RQ are extended to X and Y respectively. All right, and triangle ABX is equal to triangle PQY. So prove that the two triangles are congruent. All right, so in this case we have the diagram. So in this case AB, all right, AB is equal to PQ, then BC is equal to QR, all right, and ABX. So exterior angle ABX is equal to PQY. All right, so in this case angle 1 is equal to angle 2. So in this case to show that triangle 1 is congruent to triangle 2, if we can only show angle ABC, let us name this as angle 3 and this is angle 4. So if we can only show that angle 3 is equal to angle 4, then we can show that the two triangles are congruent. All right, so now in this case we know that angle 1 is equal to angle 2. So now in this case we know that angle 1 plus angle 3, what pairs of angles do they form? Linear pair. So angle 1 plus angle 3, their measurement is equal to how much? 180. So here also same case, angle 2 plus angle 4 is equal to 180. What is the reason? Linear pair. Since the sum of the measurement of the two angles are equal, so we can show that since their sum is equal to 180, and in this case also it is 180, so therefore angle 3 will be equal to angle 4. All right, so now we can show that the two triangles are congruent. All right, so let me write the written portion for you all. All right, given, so you write we have all right, so you write we have AB is equal to PQ, BC is equal to QR, and angle ABX is equal to angle PQY. All right, then to find, what do we have to find? So in this case to find, we have to show that triangle ABC is congruent to triangle PQR. All right, so solution So you write we know angle ABX plus angle ABC is equal to 180. You name this as equation 1. Reason: linear pair. Again, in triangle number 2, angle PQY plus angle PQR is equal to 180. So we name this as equation 2. Reason: same, linear pair. So from equation 1 and 2 we have, so ABX plus angle ABC is equal to angle PQY plus angle PQR. Alright. So 180 they will get cancelled. So here we will write angle ABX plus angle ABC is equal to angle ABX plus angle PQR. Now here, before it was PQY, now I have substituted by angle ABX. So what is the reason for this? Very simple, it is given from the question. Angle ABX is equal to PQY. So in place of PQY, we will substitute by angle ABX. Alright, so here you can write, since PQY is equal to angle ABX from the question. So here ABX will get cancelled. So angle ABC is equal to angle PQR. Alright, so we name this as equation 3. So here we have proved that angle 3 is equal to angle 4. So therefore now we can show that the two triangles are congruent. So you will write here, in triangle ABC and triangle PQR, AB is equal to side PQ. Alright, that angle ABC is equal to angle PQR, and BC, side BC, is equal to QR. Alright, so this is side angle side. So therefore triangle ABC is equal to triangle PQR by side angle side. So that is triangle ABC is congruent to triangle PQR. Alright, by CPCTC. So alright, I forgot to mention, the full form will be corresponding parts of congruent triangle are congruent. Alright, so this will be your answer for question number 8. Alright student, we will be starting with exercise 7b. So before starting with exercise 7b, there are some theorems that we should know which will help us in solving this problem, and those theorems will be angle side angle congruence criteria. So in the first case we have done side angle side, so now we will be doing angle side angle. All right, so angle side angle, so it simply means that if we have two triangles, all right, so if we have two triangles, so this is triangle ABC, this is triangle PQR. Now if angle B is equal to angle Q, all right, is equal to angle Q, then side BC is equal to side BC is equal to side QR, and angle C is equal to angle R, then it means that the two triangles are equal. All right, so it simply means that triangle ABC is equal to triangle PQR. All right, by angle, side, angle. So therefore triangle ABC is congruent to triangle PQR. All right, by CP CTC. So it is exactly the same thing as side angle side, but in this case we will be showing angle side angle. All right, now this will work only if the question says that the angles are equal to the corresponding angles. Otherwise we have to prove it that the angles are equal, and then we can use this angle side angle. All right, so that's very simple to understand. Also, another important theorem is this one: if two angles of a triangle are equal, then the side opposite to them are also equal. So in this case we can look at this diagram. If angle B is equal to angle C, all right, so this theorem is very important. If angle B is equal to angle C, then we can say that AB is equal to AC. All right, so very important, this theorem. Once again I will repeat: in a triangle ABC, if AB is equal to AC, then it simply means that AB is equal to AC, like vice versa. All right, if AB is equal to AC, then we can say that angle B is equal to angle C. And also if angle B is equal to angle C, then it simply means that AB is equal to AC. All right, another part is another important theorem is side. This also it's very easy to understand. Suppose if we have two triangles, all right, this is triangle 1, this is triangle 1. If AB is equal to RQ, BC is equal to QR, and AC is equal to PR, then we can say that the two triangles are equal and they are congruent by side. All right, so that's very simple to understand. So let us start with exercise 7b. All right, students, so let us start with exercise 7b. Now PQR is a triangle in which PQ is equal to PR and S is any point on the side PQ. So through S, what do? We draw a line, all right, parallel to QR and intersecting PR at T. So prove that PS is equal to PT. All right, so let us take a look at the diagram. All right, so let us read the question again. Now PQR is a triangle. Now in this case, what happened? PQ is equal to PR. All right, given from the question. Now S, now through S, so S is any point on PQ. All right, so S is any point on PQ. We have to draw a line. Which is parallel to QR. So when we draw a line, it will meet T at PR. All right, and according to the question, ST, all right, is parallel to QR. So in this case, what do we have to prove? We have to show that PS is equal to PT. PS is equal to PT. All right, so let us solve this one. So just let us look at the diagram. So according to the question, PQ is equal to PR. So by theorem, we know that if PQ is equal to PR, therefore angle Q will be equal to angle R. All right, clear? Because angle opposite to equal side of a triangle are equal. This is from the previous theorem. So okay, so how do we prove PS is equal to PT? All right, now another important condition is that we know that ST is parallel to QR. So if ST is parallel to QR, it means that the distance between them are equal. So if they are equal, it simply means that angle Q will be equal to angle S, corresponding angles. All right, and here angle R will be equal to angle T, corresponding angles. So now we know that angle S is equal to angle T. All right, now since the two angles are equal, then from this theorem, all right, then from this theorem, see, if two angles of a triangles are equal, then the side opposite to them are equal. So in this case, if S is equal to angle T, so therefore PS will be equal to PT from theorem. So hence we have proved that PS is equal to PT. Alright, so let us write the written portion. See, once you know the theorem, once you know the different pairs of angles, it becomes very, very easy to solve. Alright, given, so given, you will write it down by yourself. Now to find, what do we have to find or to prove? Alright, to prove that PS, side PS is equal to side PT. Alright, solution. Alright, so solution, you write we know in triangle PQR, since PQ is equal to PR, so therefore triangle PQR is equal to triangle PRQ. Alright, and what is the reason for this? Angles opposite to equal sides of a triangle are equal. Alright, now again, since QR is parallel to ST, alright, this one, since QR is parallel to ST, so Q will be equal to angle Q will be equal to angle S, and angle R will be equal to angle T, corresponding angles. So therefore angle angle PQR is equal to angle angle PQR is equal to angle PST. And what is the reason for this? Corresponding angles. Also angle PRQ is equal to angle PTS. What is the reason? Corresponding angles. All right. All right, now next now we have to prove that angle S is equal to angle T, but angle PQR is equal to angle PRQ. All right, from we name this as equation 1. From equation 1, so therefore angle PST is equal to angle PTS. All right. So in this case, we have proved that angle S is equal to angle T. So here it becomes very easy. We can show that PS is equal to PT since the two angles are equal. So in triangle PST, since angle PST is equal to angle PTS, alright, so therefore side PS is equal to side PT. Alright, the reason is side opposite to equal angles in a triangle are equal. So hence PS is equal to PT. Proof. Alright, so this will be your answer. Alright, student, next we will start with question number 4. So question number 4, ABC is a right angle triangle in which angle A is equal to 90 degree and AB is equal to AC. So you have to find angle B and angle C. So question number 4, it's very simple. I want you all to try it by yourself. Alright, so next what we will do is we will start with question number 6. Alright, so in the figure, AB is equal to CD and AD is equal to BC. Prove that triangle ADC is equal to triangle CBA. Alright, so let us prove that the two triangles are equal. So we have AB, alright, side AB is equal to side DC, and AD, so AD, alright, will be equal to BC. So in this case, what we have to show is that triangle ADC, so this triangle is congruent to triangle ABC. So this one is very simple. We already have the two condition, AB is equal to CD and BC is equal to AD. So we just need to find the third condition. So the third condition in this case will be AC is equal to AC. So it will be the common line because both these two triangles are sitting on the same line AC. So AC will be the common line. Alright, so in this case we have found out the three properties, that is AB is equal to CD, then BC is equal to AD, and AC is equal to AC. Why? Because it is the common line for the two triangles. So in this case the two triangles are equal and they are congruent by side. Alright, so given, you will note it down by yourself. Then to prove, what do we have to prove? That triangle ADC is congruent to triangle CBA. Alright, then proof. Alright, so you write in triangle ADC and triangle CBA, AB, side AB is equal to side CD. Alright, given from the question. Then BC, side BC is equal to side AD. This is also given from the question. And the last condition, AC is equal to AC. This is a common line in which the two triangles are at. Alright, so therefore triangle ADC is equal to triangle CBA. Alright, by side side side. So that is triangle ADC is congruent to triangle by CBA. All right, by corresponding parts of congruent triangles are congruent. All right, so this will be your answer. All right, students, so we'll be doing the last question, that is question number 8. All right, for this exercise. So in the given figure, O is the midpoint of each of the line segment AB and CD. So prove that AC is equal to BD and AC is parallel to BD. So in this case, now O is the midpoint. So if O is a midpoint, it divides AB into two equal parts. So AO will be equal to OB, and also since O is the midpoint of CD, so therefore OD will be equal to OC. All right. So in this case, what do we have to show? We have to show that side AC, all right, side AC is equal to side DB. All right, so in this case it's very simple. This is triangle 1, this is triangle 2. So the two conditions we have already given. AB is equal to AO is equal to OB and OD is equal to OC. So in this case, angle 1 will be equal to angle 2. What is the reason for this? Vertically opposite angles. So we have gotten the three condition, that is side, angle, side. All right, so it means that the two triangles are equal and they are congruent. So if they are congruent, it simply means that AC is equal to DB. All right, so that is the first part of the condition. We have proved that AC is equal to BD. Now for the second part of the condition, we have to show that AC is parallel to BD. So how can we show that AC is parallel to BD? So we can only show that AC is parallel to DB only if angle A is equal to angle B. All right, we can show that if we can only show that angle A is equal to angle B. So in this case, we know that angle OAC is equal to angle OBD. So what is the reason for this? By CPCTC, that is congruence of the corresponding parts of a congruent triangle are congruent. So in this case, we can say that angle OAC is equal to angle OBD. All right, and we can also say that BAC is equal to ABD. All right, because they are the same angle. So, and we can also see that angle A and angle B, what pairs of angles do they form? They form alternate interior angles. So if they form alternate interior angles, it simply means that AC is parallel to DB. All right, so let us write the written portion now. All right, given, you will note it down by yourself. Then to prove, number 1, we have to show that AC is equal to BD, and number 2, we have to show that AC is parallel to BD. All right, so proof. So you write in triangle AOC and triangle BOD, AO is equal to OB. All right, since since O is the midpoint of AB. Alright, then angle AOC is equal to angle BOD. So what is the reason? Vertically opposite angles. And also OC is equal to OD. Since O is the midpoint of CD. Alright, so therefore triangle AOC is equal to triangle BOD by side angle side. So which implies that triangle AOC is congruent to triangle BOD by corresponding parts of congruent triangles are congruent. Alright, so since the two triangles are congruent, we can say that which simply implies that AC is equal to BD. Alright, so we have proved that AC is equal to BD. Alright, so this is also by CP/CTC. Alright, so now next since we have proved that AC is equal to BD, next we have to show that AC is parallel to BD. So like I've told you, if angle A is equal to angle B by any pairs of angles, then we can say that AC is parallel to DB. Alright, so let us write down the written portion. Also angle OAC is equal to angle OBD. Alright, this is by CP/CTC. Alright, the corresponding parts of congruent triangles are congruent. Since we have proved that the two triangles are congruent, which implies that angle BAC is equal to angle ABD. Alright, what is the reason for this? Because since they are the same angles, so here it is angle A equal to angle B, here also angle A is equal to angle B. So I will write the reason here. Since angle OAC and angle BAC are the same angle, BAC are the same angle. Alright, and another condition also, angle OBD is equal to angle OBD and ABD are the same angle. Alright, but angle BAC and angle ABD, so BAC and ABD, so what pair of angles they form? They form alternate interior angles. But angle ABC and angle ABD are alternate interior angles. Alright, so therefore since the two angles are equal, we can say that AC is equal to BD. Proof. Alright, so this will be your answer. So for homework, I need you to do question number 9. Alright, so 9 almost similar to question number 8. You can try it by yourself. Alright, so that's all for today.